If you missed the very end of that last clip there, we said that triangle JKL is similar to triangle NML, and that would be by angle because there are two angles in each triangle that correspond to each other and are congruent. So example 4, using the angle-angle postulate. So here's an example using it. So if we look here, again, this angle and this angle are congruent because they're vertical angles. So that would be angle ACB is congruent to DCE. And then if we look here, we have a second angle, angle 96, or angle B and angle E are congruent. So we have two angles on each side. So based on angle, we can say triangle ABC. Notice the A had no marks on it, so I'm going to start on D because it has no marks. And that is similar to triangle DEC. Again, make sure your marks match so that the congruent angles are in the same position. Like the C and the C are both congruent, the E and the B are congruent, and they're in the middle. So now to solve for x, x would be this side. We haven't talked at all about sides, but because of angle, this shortcut, this is my favorite one because it's the shortest one of all, we know all the sides are definitely proportional. So I'm going to take this side from the small triangle and I'm going to set up a proportion to x. So this is from the small one, and that compares. Look at this side has no marks on it, and this side has 2. So A has no marks, B has 2, so it must go with this 36.9. X over 36.9 be equal to, now these two are corresponding here, but there's not a number here, so I'm not going to do the 44. I'm going to use these two. There's no mark on D to the single mark, no mark on A to the single mark, so 32.2 on top over 60.5 on bottom. And again, to multiply or to solve this, we cross multiply and we get 60.5 times x equals 1188.18. Then divide both sides by 60.5. I get x equals about 19.64. So this x is 19.64. That's it.